All right, good morning or afternoon, depending on what time of video you're watching this. Bellringer fans, living environment fans, it's been a nice week off, plus a little extra. We had a snow day right before, that was pretty nice. Hopefully it was restful and relaxing so that now you are back here in class to watch this Bellringer and start a new week of lessons. Let's go. Da 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 do 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 da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. When we last met, we were learning and trying to master the difference between transcription and translation, right? Transcription and translation is how messages are sent from the nucleus, genes, to ribosomes to make proteins. Transcription is the copying of the gene. Translation is the making of the protein, right? Transcription, of course, that happens in the nucleus, and that involves RNA. Right? So you got to unzip the DNA and pair up A's with T's, C's with G's, except for in mRNA, there is no time for T, but they do care about you, right? But it's found in RNA that's not found in DNA. Good. Right? So transcription happens in the nucleus. It's similar to replication, but in replication, you make double strands. You make copies of the DNA molecule. In transcription, you only make single strand copy of 1/2 of the DNA molecule, copy of a gene. Right? Transcription happens in the nucleus with an enzyme called RNA polymerase, and the messenger RNA floats out of the nucleus out into the cytoplasm. There it binds to a ribosome. At the ribosome, the code, the A's, C's, U's, and G's, we call them the code of the genes, right? Tell the ribosome which piece of amino acid to add to the chain next, right? A's, U's, C's, and G's. And then, of course, tRNA molecules bring the pieces over, and they attach to each other with peptide bonds, and then eventually you get a protein, right? So that's what we were studying right before we went on this beautiful break. And we also were studying, remember, DNA fingerprinting, and that leads us to, our next topic is how do genes get passed from parents to offspring? What's the mechanism, right? And that's what we're going to be talking about. Okay? And we talked about how everybody has a unique genetic fingerprint, right? These bands represent pieces of DNA that have been cut, and they're all different sizes. The smallest one travel the farthest, right? But if you cut DNA in the same place, you get fragments of different sizes, and it's always going to sort out the same way in an individual. So that's why everybody has a unique DNA fingerprint, right? It's really a DNA size print. But that's what we were studying. And then one of the things we're going to do and talk about a little bit is, can you imagine if your DNA that you're born with, if they collected when you're born and were able to tell things about you, like your risk of developing certain cancers and those kinds of things right at the beginning, and could it be used to discriminate against you? I don't know, like an insurance company or something like that. In fact, that's what we're going to be doing in lab over the next day, is we're going to watch a film called Gattaca. Well, we're going to watch the first part of Gattaca, and then just to get the idea of what's going on. But Gattaca is a film starring Ethan Hawke, Uma Thurman, and Jude Law. And it's about exactly living in a world where DNA is your destiny. And of course, it's a dramatic film, so it's got some plot twists and turns, and I think you'll like it. But I'm only going to assign you the first third of it, And then if you want to watch the whole movie, I'll put it up for you to watch as extra credit. But that's what you're going to do in lab today or tomorrow if you don't have lab today. All right? Good deal.